We need to do cosine of sine inverse minus tangent inverse. And you may notice this is slightly different than some of the problems we've been doing because it has two inverse trigonometric functions in it. So we're going to have to draw ourselves two triangles for each of our inverse trigonometric functions. So let's think of sine inverse. Remember, sine inverse, we're plugging in a number, which is 3/5, and the answer that comes out of a sine inverse is an angle. Let's call it alpha. Tan inverse, we plug in a number, which is 12/5, and out comes an angle. Let's call it beta. For each of these, we know that the sine of that angle alpha that comes out is 3/5. And since we're plugging a positive number into a sine inverse answers angles only come from two quadrants, 1 or 4. Since it's a positive number, 3/5, we know that this is going to be in the first quadrant. Tangent inverse of 12/5, tangent inverse answers only come from two quadrants. And since we're plugging in a positive, we know that this answer beta is going to come out in the first quadrant as well. So we can draw the reference triangle in the first quadrant for our angle beta. And what do we know about these two angles? Well, sine, SOHCAHTOA, sine is opposite over hypotenuse. So the opposite of angle alpha is 3, and the hypotenuse is a 5. We know tangent is TOA, opposite over adjacent. So the opposite of angle B is 12. The adjacent is a 5. Now we can use Pythagorean theorem, and that will help us find that the adjacent for the alpha is 4, and the hypotenuse for the beta is 13. Now, do we need to put pluses and minuses on any of these? Well, since these angles are in the first quadrant, we know that all of the legs are going to be on the positive x and the positive y axis. So none of these need negatives. But how is this going to help me solve the problem that I have in the first place? Well, if you think about it, this is asking me to find the cosine of sine inverse minus tangent inverse. But I just said that sine inverse is going to be equal to alpha. So let me replace that with an alpha. And that tangent inverse, I said, is going to give me an angle beta when I calculate it. Remember, the answer to a tangent inverse is an angle. So what do we have here? Cosine of alpha minus beta. Does that look familiar? It should look familiar because if we look at our formula sheet, cosine of alpha minus beta was one of our trig identities that we had. It was the cosine cosine plus sine sine trig identity. So we're going to go ahead and write that trig identity down. The cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Now we'll look at our triangles alpha and beta and find the fractions that that gives us. So cosine of alpha, adjacent over hypotenuse, that's 4 over 5. Cosine of angle beta, adjacent over hypotenuse, that's 5 over 13. Plus sine of alpha, so opposite over hypotenuse, that's 3 over 5. Sine of beta, use the beta triangle, so opposite over hypotenuse, 12 over 5, 12 over 13. Now, all we have to do is put this into our calculator very carefully or use other methods to solve this, and we will get that this is going to be negative 16 over 65. Oh, sorry, that's wrong. Now, if we take all of these and put them into our calculator very carefully, we're going to get that this is going to be 56 over 65. And so we have our final answer. Let's try that one more time. Let's look at this next guy over here. So we have cosine of 2 sine inverse of negative 1/2. What we're going to do is ignore that little 2 for a second and just look at the sine inverse. So we're going to call this our angle theta. Remember, when we take the sine inverse of a number, the answer that comes out is a angle. So we'll call that answer angle theta. Since this is sine inverse, we know all of these are going to end up, angles are going to end up in either 1 or 4. The answers to sine inverse end up in quadrant 1 or 4. And since we're taking the sine inverse of a negative, we must be in quadrant 4. What do we know about this angle? Well, we know that the sine of angle theta is negative 1/2 because that's how we defined it. It's the sine inverse of negative 1/2. So its sine must be negative 1/2. So we know its opposite over hypotenuse is 1/2. Using Pythagorean theorem, leg squared plus leg squared is equal to the hypotenuse squared. We get that a squared is equal to 3, so the missing side must be the square root of 3. Now we need to watch our pluses and minuses. Well, on this triangle, we're going right on the positive x-axis, so that square root of 3 will be positive, but we're going down on the y-axis, so that 1 is going to have to be a negative 1, which is where the negative on the negative 1/2 comes from. Now, let's go back up here. What are we doing? This is the cosine of 2, but remember we defined sine inverse to be theta. So this is the cosine of 2 theta. Does that look familiar? It should. If we look at our formula sheet, cosine of 2 theta or cosine of 2x, we had 3 different ways to calculate this. So I'm going to use this third one down here because I think that this will be the easiest one for me to figure out. So cosine of 2 theta or cosine of 2x is 1 minus 2 sine squared of x. So I'm going to write that formula down. 1 minus 2 sine squared of x. Well, what is the sine of our theta? So opposite over hypotenuse. That's negative 1/2, but it's sine squared, so I need to square it. So this will give me 1 minus 2 times 1/4, or we're going to end up with a final answer of 1/2.